Nina Mahfoud from drys.com, and this is the new series of our tutorial videos, which is produced by our technical Mr. Nipe.
Hi.
I will translate it into English. It's about understanding the power and charge circuit using the schematics. It's an amazing video. It's for free, and we will email it to all of our members all around the world, so don't miss it.
In this video, I want to talk about the power block in the schematics. The power block of all the laptops are divided into some separated parts. For example, in this schematic, as you see, there is an adapter here, which means the laptop has two power supplies. One is the adapter and the other is the battery. Adapter has two obligations. It converts AC power to the required DC of the laptop and also charges the battery. And when adapter is not plugged into the laptop, battery provides power and DC for the laptop. The battery provides power of the laptop by the selector. All of these parts are controlled by the microcontroller, and the microcontroller is connected to the I/O. As you can see, the adapter and the battery voltage goes to microcontroller, and the microcontroller has direct and mutual connection with the I/O. And adapter is connected to I/O, the laptop is connected to the I/O, and the battery is connected to the I/O as well. This block, this whole set provides the required power of the laptops by the switchings and drivers that are on selector block. So with this introduction, I can now explain schematics accurately and easily. But before that, I need to explain the numbers and the letters that you see in the schematics. For example, this component is a fuse, PF101. PF101. P means power. F is short for fuse. And 101 is the fuse number in this schematic. With 7 ampere which is the maximum current, 24 volt is the maximum volt, and the rest of the letters and numbers are the size and manufacturer codes of the fuse. The next component that I want to explain and I want to talk about is the capacitor. You can see the two capacitors here, PC101 and PC102. PC101 has 1000 picofarad capacity, and O402 is the standard built size of the capacitor. 50V is the maximum work voltage of it, and the next letters are the capacitor's error percentage. PC102 has 100 picofarads with 50 volt. The maximum is 50 volt. The next component is the coil. There are two coils here. PL101. As you see, there are two inductors in here, PL101 and PL102. As I said before, P is power, So this inductor or coil is power inductor. It's related to power, and its number is 101. And the specifications are written as well. Next signs or symbols that I want to talk about are the arrows that you might see in all the schematics as well. Let me zoom in. This arrow directs us to an address. The number on the bracket directs us to a page. It means the following of the circuit is on page 33. There is a resistor here, PR 101. It's a power resistor with these specifications. 750 ohm is its resistance, 0402 is its size, and 1% is its error percentage. I want to show you a list related to these, the size 0402. As you see, standard sizes are shown here. 0402 standard size shows the length and width of the resistor. 75 mils to 1.9 millimeter. There are other sizes as well, as you can see. For example, 0805 is 120 and to 3.05 mils. Let me talk about other signs as well. For example, the triangle sign that you see, it means ground or G and D. It is displayed like this in another schematics, but it is displayed as a triangle in this one, which is ground or G and D. It is ground or negative. The next component is, let me show you. The next component is PQ101B. PQ101B. PQ means the transistor of power block. 101 is its number in this schematic. We have PQ101A in another part of this schematic as well. Let me show you that too. Let me show that to you too. This is PQ101A. A and B means, look at the pins of this transistor. Pin 1, pin 2, and pin 6 are here. And pin 3, 4, and 5 are here. It is actually one transistor, which its pins are drawn separately in two different parts. The next element is a Mosfet. PQ303. PQ303. It's a Mosfet transistor. One thing about the Mosfets is that you should pay attention to the arrow. If their arrow is pointing in, it is an N channel. But if their arrow is pointing out, it is a P channel. And as you see, the arrow is pointing out in here, so PQ303 is a P channel Mosfet. Another thing about Mosfets is that you should pay attention to this part as well. That's the line. If this part is a cut line, something like this. The Mosfet is an enhancement mode, and if the line is continuous, it is a depletion mode Mosfet. So the next component that I want to talk about is diode. The symbol of diode is like this. This side is cathode, and this side is anode. PD302. PD302 is the second power diode of the battery block. The next component is a digital transistor, PQ306. And as I said before, it's a power transistor. The hundreds number means that it is in battery block, and it's the sixth transistor of the battery or charge circuit. And DTC means digital transistor. As you see, there are two resistors inside it between the base and emitter. DTC is a digital transistor, and 115 is its number. There are two types of transistors. If the arrow is pointing out, it is NPN. And if the arrow is pointing in, it is a PNP, which is positive. NPN transistor is minus or negative, and PNP transistor is a positive. As you see, PQ306 is a negative transistor, means NPN. The next component is a Zener diode, PD301. It's not different from diode by letters, it's totally the same, but the symbol is a little different. This is the Zener diode's symbol, and this one is the normal diode's symbol. And as you see, this is Zener. In this part, I want to talk about charge and discharge circuit of the battery and adapter function in schematics. First, let me show you the inputs. There is an adapter, a Lenovo adapter. Let me show the specifications too. With 90 watts and 20 volts. It's a Lenovo, as I said. 101 to 240 volt of AC power input. And the output is 20 volt and 4.5 ampere. And this is a battery with 14.4 volts and 32 watts per an hour and 2200 milliampere per an hour as well. They are two power inputs. As you see, this is a motherboard. This is the first jack, which is the power input. There are two red wires which are positive, and the two black wires are negative. And the blue wire is the fifth pin of the jack for detecting adapter plugging in. I'll start analyzing schematics from here. As you can see, this is the adapter jack JDCIN1. It means DC input jack of adapter. Its code is 1. There are many components in here. Let me show you some. This is PF101 or PQ101A or PR101. or the capacitors are PC 101, 102, and so on. As you see, 1 in this jack is the naming or coding base in the schematic. It is the same as all the hundreds of these components. The number of components can be more than 10, so they chose hundreds for the number. So PR101 is the resistor of power block and is related to the adapter, means jack 1 of the adapter. So PR101 is the first resistor of the adapter. So the last two numbers mean the code of the component. O1 is 1, PR 101 is the first resistor, and PR 102 is the second resistor, which are in input jack of DC. Let me show you the other blocks as well. For example, in this part, as you can see, battery jack starts with code 3. All the components that starts with code or number 3 in schematic, for example, PL 301, PR 302, PC 324, the capacitor. As you see, the hundreds number is 3. Or PC 308, or the other components are exactly like that too. For example, PQ 306, or diode PD 302, PD 303, or the Mosfets PQ 303. Let me write it for you, PQ 303. So if the hundreds number is 3, it is related to battery or battery charge circuit. And the parts that I showed in the beginning of the video, the microcontroller, the selector, all of them start with 3, which is related to the battery block. I want to analyze charge circuit of LA/B 102P motherboard, and the revision is 1. I'll start with input jack of adapter. As you can see here, first jack is JDCIN1, JDCIN1. It is the power input from the adapter. Pins 1 and 2 of this jack transfers 20 positive volt to the laptop. And pins 3 and 4 are negative, which are connected to ground or GND. And and when you plug adapter to the system, Pin 5 sends a voltage for a short amount of time, like 2 or 3 seconds, and detects that the adapter is plugged to the circuit. Positive voltage of the adapter enters circuit through fuse PF101. And if there is a disconnection, the fuse does its job. It means it disconnects the circuit. And with the set of the filters that you see here, 2 coils and 3 or 4 capacitors, they filter the voltage. They filter the voltage noise, which include PC101 and PC102 capacitor filters. Filter of PL101, 102, and PC103 and 104. So this set of filters and LC filters are for filtering and clearing noise that might come from the power or even the different parts or disconnections of adapter jack. So eventually VIN, the input voltage, as you can see in here, is provided in here. It is 20 positive input volt of the adapter. I'll explain pin 5 now. Pin 5 is for detecting entrance or plugging in of the adapter to the laptop, which does it through the Mosfet PQ101 and is connected to the I/O. There is 3 volt of power always here, and this is input voltage of adapter, the 20 volt, that activates the Mosfet's pins, and laptop detects that the adapter is plugged in through these 2 pins. I'll explain and analyze battery jack in the following. There are 2 battery jacks in here, as you can see, jack 1 and jack 3, which are connected to each other on the motherboard. They are placed on each other on the motherboard. Odd pins on jack 3 from pin 1 to pin 25 are positive pins of the battery, and even pins on jack 3 that are connected to each other from pin 2 to pin 26 are connected to the ground of the battery, which is negative. And the other pins, or the rest of the pins of the battery, as you can see in here, pins 28 and pin 30, have different directions. You can see where they go up here. Pin 30 is connected to ECSMDA and pin 28 is connected to ECSMCA. What are these for? As you see, they go to page 33 and 39 after passing through PR217 and PR201 resistors. As you can see in here, these are the pages. And then there they are connected to IOIC. Why? Pin SMDA comes from data. and pin SMCA comes from the clock. Data and clock. A question may arise here: how does data and clock relate to the battery? I should say that there is a microcontroller inside the battery as well as the laptop. The information of clock and data are used to synchronize these two microcontrollers so that the laptop detects if battery is being charged, fully charged or empty, and the signs or blinking LED lights for full charge of the battery are related to IOIC. So the positive voltage of pin 1 and pin 2 comes through fuse PF201 with 12 ampere and 65 DC volt. Maximum volt is 65. And the filters PC201, PL201, PL202 and PC202. So through these components, the 14.4 battery voltage is being provided by BATT positive. As you see, this is the charge circuit, and as I said before, there are two voltage inputs. VIN input comes from the adapter and battery. Comes through three transistors, PQ301, PQ302 and PQ303. That all of these components are controlled by the microcontroller PU301 BQ24727 RGRR. It is the microcontroller. I want to explain how these components work now. By the time of plugging the adapter to the system or laptop, and when VIN is present in drain pin of Mosfet of PQ301, microcontroller activates the PQ305 and PQ304 driver transistors, and the gate pin of Mosfet will be activated and voltage will be present in source pin of PQ301, and then this will be a locked key, which was unlocked before plugging the adapter. At the same time, with the drivers, the gate pin of PQ302 will be activated, and the PQ302 will act as a locked key, and voltage in P3 means 20 volt is here. So by the time of plugging the adapter to the laptop, PQ301 and PQ302 act as locked keys and lead the voltage. And in the battery block, when the adapter is not plugged to the laptop, 14.4 volt of the battery will be present in drain pin of PQ303, and by activating gate pin, which is the fourth pin of PQ303 Mosfet, by the microcontroller, the voltage will be present in source pin of this transistor and will act as a locked key. So the laptop has two modes here. Let's assume that the adapter is not plugged, battery is in the laptop. Through the PQ303, which, as I said before, is a locked key, the main voltage of the laptop, B+, will be provided through the PQ303. And as I said before, when adapter is plugged to the laptop, the voltages of PQ301 and PQ302 will be leaded. And the voltage of source pin of PQ303 will be enhanced to 20 volts from 14.4 volt. 14.4 goes to 20 volt. And PQ303 will be reversed and acts as a disconnection key. This means the battery is out of the circuit, so there won't be 14.4 volt present in B positive, and instead there will be 20 volt. So this is how PQ301, 302, and 303 work. When adapter is plugged, PQ302 and PQ301 will be active and transfer 20 volt to B+. And when these are disconnected, PQ303 is leaded and there will be 14.4 volt present in this part. All of this happen by drivers and the transistors that are in this part or in this block. For example, PQ306. As you see, it has an input voltage, VIN, which is the adapter voltage. When the adapter is plugged into the laptop, this transistor will reverse PQ303 so that it will be disconnected. Let me show you another block. PQ304, PQ305, or even PQ307, and all the resistors and all of the capacitors have the obligation to activate two keys, which are PQ301 and PQ302. Let me show you in a picture so that you can understand this whole thing easily and accurately. This is the picture. As you see, VIN, which is up there, this is the input voltage of the adapter, and this one is the input voltage of the battery. I can explain this process in three ways. One, only the battery is connected to the laptop. What happens in this time? When the battery is connected, the microcontroller, which detects if the battery is connected or not, it activates gate pin of P303, and this will transfer the voltage as a locked or closed key. And when the microcontroller activates the gate pin of PQ302, so the voltage will be present in B+, P3, and P2, which is 14.4 volts, in the three main parts. these three main parts. You can easily check the voltage. When the laptop works normally and all the components are okay, the battery is connected but the adapter is not plugged, 14.4 volts should be present in P2, P3 and B+, which is enough in order for the laptop to work. 2. Let's assume that the battery is not connected but the adapter is plugged. VIN is present, which is 20 positive volts, but 14.4 of the battery voltage is absent. In this way, microcontroller leads PQ301 and PQ302, and the voltage will be present in P2, P3, and
B positive.
20 positive volt. So the voltage will be absent in battery block and the charger won't work. 3. Both adapter and battery are connected to the laptop. There is 20 volt present in VIN and P2, which means PQ301 and 302 are connected. First and second keys are connected, and 20 positive volt is present in P3 and B+, and 14.4 volt is present in the battery. This means 14.4 volt is present in drain pin of PQ303 and 20 volt is present in source pin of PQ303. So PQ303 Mosfet will be reversed and disconnected. And this means PQ310 and 312 are needed for charging the battery. In fact, when adapter and battery are both connected to the laptop, PQ301 and PQ302 are connected for leading the voltage to the laptop. And PQ310 and PQ312 MOSFETs act as the connecting keys for charging the battery. This is a very simple and easy explanation of the power circuit. Hope you enjoyed watching the video. Take care of yourselves and stay with us. Bye-bye.